welcome to This Explainer. Today, we're jumping right into something that's honestly pretty wild, the astonishing rise of automated robotics and the hidden high-stakes cybersecurity war happening right under their hoods. We are literally standing on the precipice of a massive technological shift. Machines are evolving, right? They're moving from just being tools that we operate to intelligent entities that operate themselves. But here's the catch. As we hand over the keys to the software, we're also opening the doors to some unprecedented risks. So let's explore the incredible promise and, frankly, the terrifying peril of automation.
Now, you might be wondering, why is this shift happening so incredibly fast? Well, we kind of have to look in the mirror for that one. The U.S. Department of Transportation reported a staggering statistic. 94% of vehicle accidents are caused by human error. 94%. Whether it's distraction, stress, or just plain poor judgment, we are basically the weakest link on the road. So this rush toward fully automated systems isn't just about convenience. It is an absolute necessity for public safety. We are actively trying to engineer the human flaw completely out of the equation.
All right, let's get into the automation revolution, specifically looking at cutting-edge robotics. Because, it's not just about cars. Researchers are developing some truly mind-bending innovations to replace humans in dangerous or super complex tasks. We're seeing jaw-dropping advancements across the board. For example, we've got autonomous drones that can inspect 10 kilometers of power lines, which is absolutely crucial for maintaining our civil infrastructure. Then there are these flapping winged robots designed to mimic actual biological flight. And maybe the wildest one to me, these marsupial robotic systems. Just picture this, a ground rover carrying a drone in a literal pouch. When they hit an area with no GPS, the rover deploys the drone and then keeps it continuously powered through a tether for these really long duration missions. The level of autonomy we're achieving right now is just staggering. Which brings us to part 2, computers on wheels, and the rise of the software-defined vehicle. The exact same principles that are pushing robotic drones to new heights are fundamentally altering the DNA of the modern automobile. A brilliant illustration of this is the Unicar Gill project. By standardizing the base of the vehicle, they've created these incredibly diverse modular concepts. You've got the auto taxi for on-demand rides, the auto cargo for automated package delivery, the auto elf for private ownership, and the auto shuttle for public transit. These aren't just cars anymore. They are, for all intents and purposes, giant computers on wheels operating at SAE Level 4 autonomy. And this represents a massive, massive shift in engineering. Traditionally, cars were essentially closed mechanical systems. They'd have dozens of isolated computers, called ECUs, each doing one single job, like one for the brakes, one for the radio, you get the idea. But today's software-defined vehicles, they operate on an open system. They use what's called a zonal architecture with fewer but vastly more powerful computers. And they are highly connected to the outside world, constantly downloading updates and sharing real-time environmental data, like a giant web. But of course, that connectivity creates our next topic, the cybersecurity threat and an open door to hackers.
Here's the thing. A closed box? Pretty hard to hack. But an open, software-defined network that is constantly talking to the cloud? That's a completely different story. A 2020 Forbes report revealed a pretty chilling reality. According to the CEO of Owen Collective, nearly every manufacturer has been hacked. These aren't just theoretical lab exercises, folks. This is a terrifying reality today. Once an attacker manages to infiltrate a highly critical vehicle system, they can literally take control of the steering, the brakes, or the engine.
For automakers, the stakes here are unimaginably high. According to a KPMG report, 72% of consumers said they would actively avoid purchasing a vehicle brand that had experienced a cyber attack. Furthermore, 10% said they'd never buy from that brand again. In this mad dash to automate, a single high-profile security failure could utterly destroy a manufacturer's reputation and wipe out consumer trust. Security is no longer just some optional add-on feature. It is the very foundation of safety. Fortunately, there is a defense. Let's look at engineering the shield and the push for holistic security engineering. Engineers aren't just slapping a firewall onto a car and calling it a day. They're redesigning security from the ground up, and they have to start with legacy tech. You see, vehicles still rely really heavily on the Controller Area Network, or CAN bus. It's this fast, priority-based system for event-triggered data, but it was built decades ago without any inherent security in mind. To fix this, security engineers are utilizing something called lightweight implicit certificates. Think of them like digital FastPass ID badges. They allow the vehicle to instantly authenticate critical messages without bogging down the system's memory or speed.
It's an incredibly clever way to teach an old dog some new, highly secured tricks. But for the massive data requirements of modern autonomous driving, those legacy systems just aren't going to cut it. That is where ASOA, the automotive service-oriented architecture, comes in. It's a modern Ethernet-based middleware designed to handle huge amounts of real-time sensor data. To lock this down, engineers deploy a 3-stage security process that automatically distributes cryptographic security tokens to authenticate the data flow. And honestly, the best part? It operates with an incredibly low 5.71% runtime overhead. In plain English, that means it keeps the car safely authenticated without slowing down the vehicle's real-time physical reaction speed, which is absolutely critical. Defense isn't just about stopping live hacks, though. It's about proving the vehicle is safe to drive in the first place. So before an autonomous vehicle is even allowed on the road, it has to undergo a really strict validation process. It works like this. The vehicle requests an integrity measurement, which is then validated by a governmental third party, just to prove its software hasn't been compromised. Only when this digital certificate is verified is the trustworthy vehicle actually granted permission to participate in traffic. But what happens if a hacker somehow slips through all these preventative shields while the vehicle is actually driving? That brings us to reacting to live attacks and context-aware defense. A false alarm or a minor software glitch definitely shouldn't cause an autonomous car to slam on its brakes on a crowded highway, right? But a critical breach? That needs immediate action. Following ISO/SAE 21434 standards, the system instantly evaluates an attack using what are called asset dependency graphs. This is basically a real-time digital map of how a hack might spread through the car's internal networks. It assesses the probability and the context of the attack. If it detects a truly critical threat, it can deploy safety countermeasures, like initiating an emergency halt, in a fraction of the time it would take a human to react. It's essentially an automated, lightning-fast immune system for your car. So, as we wrap up this explainer, we're left with a pretty provocative thought that really challenges our comfort with the future of mobility. As our machines become fully autonomous, who is really in the driver's seat? Is it the software guiding the wheels, the security engineer building the shield, or the hacker looking for an open door? The automation revolution is definitely here, but the invisible war for control, well, that is just beginning. Thanks so much for joining me on this deep dive. Stay curious and keep learning.